Hello everyone, this is ML Naruto. Welcome to my channel. So today I'll be explaining what is meant by space complexity. So we have already seen what is meant by time complexity and we have already covered all the notations for it. So now this time I'll be covering space complexity. Okay. So first of all, what is meant by space complexity? So how do we understand the concept behind it? So first of all, this is my computer. Let's imagine this is my computer. Okay. So, in this computer, I have some kind of input. This is my input data. And in return, what I'll be getting is my output, right? So, in between the process here, there involves some kind of a function that is known as the algorithm, right? This is an algorithm. So what we are doing is we are actually passing some kind of input to our algorithm, and our algorithm will take this particular input and it will process the input and it will automatically gives us the desired output. Okay, so this is the process. And when I say input, that may be some kind of integers, like for example, a is equal to 20. This is an input, and maybe x is equal to ml Naruto. So this is a string. This is also an input, and n is equal to 95.9. This is also an input. So whatever may be the data type is, either it may be integer, string, or float. All these things are input. Why? Because we are actually giving from outside, right? We are actually passing this particular input to our algorithm from outside. So in return, we'll be getting some kind of output. So okay. So, but did you ever think, uh, for example, when we pass any kind of input, how does our algorithm will usually store that particular input? So our algorithm's job is to just process this particular input so that we'll get some kind of output. But in order to process, first of all, we need to store this particular input, right? So for that, we need some kind of a space here, or memory space, you can call it as. So this is the memory space in which we can store our variables. That is, for example, if I say a equal to 20, I can store this particular a equal to 20 here. And if I say x equal to ml Naruto, I can store this particular x equal to my string here, that is ml Naruto. Okay. And if I say n equal to 95.9, I can store this particular thing here, that is 9 equal to 95.9. So all the variables or all the input data we need to store somewhere. So that somewhere or that place where we can store our variables or the input data is known as the memory space here. So now we are here to analyze this space complexity, right? So the complexity is nothing but the time complexity means uh, we need to analyze the time here. But now the topic is about the space complexity. So we need to analyze the space for the different algorithms, right? So for the different algorithms, we need to analyze the space here. Okay. Okay. So first of all, uh, we have any kind of algorithm, right? So let's imagine this is an algorithm. So if you want to run this particular algorithm, first of all, we need some kind of input, right? So we need some kind of input to run this particular algorithm. Okay. And so if you want to pass this particular input to this algorithm, first of all, this input needs to be stored somewhere, right? So it needs to be stored somewhere. That is the storage here. That is the memory space. So first of all, you need to store this particular input somewhere. That is the storage or the memory space. This is, let's imagine this is the memory space here. Okay. What all the things we can store in this particular memory space here? That's nothing but we can store our input here. We can store our input, and we can also store some kind of intermediate and temporary data. What is mean by that intermediate and temporary data here? For example, uh, I'll explain you some kind of small piece of code later in this video. Then you will definitely get understand what is meant by this intermediate and temporary data. Okay. Um, okay. For example, see, let's imagine. For example, a equal to maybe 20. Okay, and then mm, I'm saying if a is equal to 20, then I'm saying print hi. Okay, and I'm also saying else print by. Okay, this is a small bit of a small piece of code. Okay, so here what I'm trying to say is, see here, a is equal to 20. This is nothing but our input data, right? So this input needs to be storage. This input needs to be stored, right? For example, let's imagine we have some kind of a memory space. This is our storage. Let's imagine. So this input needs to be stored here. Okay. Let's imagine I have stored my variable a. Okay. And also I have already told that my Python to check the condition. The condition here is I want to know whether the variable a is equal to 20 or not. Is it equal to 20 or not? I need to know that. If it is equal to 20, then I'm saying print high. Okay, or else I'm saying print by. So here, this if a is equal to 20, here I'm checking this condition, right? So for that I need to it needs some kind of space. It also needs some kind of space here, right? So if you want to check this particular condition, it also needs some kind of space here. So for that also we need to store that in our storage or the memory space here. You need to store this particular condition here, and also you need to store this particular else condition also here, right? So likewise, these conditions are all nothing but the intermediate or the temporary data. Okay, this a is nothing but the input data. So whatever may be the data is, either it may be input or it may be the intermediate or it may be the temporary data, whatever it may be, all those data should be stored in some kind of a storage called memory space. Memory space, right? So now, and memory space is that thing in which we can store our variables, that is this input data, and we can also store some kind of instructions. This is nothing but an instruction. If a is equal to 20, then do this, right? Or else if a is not equal to 20, then do this. These are all the instructions. These instructions also need to be stored in this particular memory space, right? So what I'm trying to say is, what I'm trying to say is, in our storage, in our memory space, you can call, in the memory space, we can store the variable, and we can also store the program instructions, and we can also uh, executing, and then we execute the program and we get the result. So this result also will be stored in some kind of a storage space, right? So we have a memory space or the storage space in which we can store the variables, and we can also store some kind of instructions that are passed inside our program, and we can also store the final result that is being produced in our program, right? So we, in this memory space, we will do lot more things like this. Okay, and now I'll be showing you some small piece of code. Using that, you will definitely get understand what is meant by this, right? Okay, so here, see here, I have defined some kind of function. This function is used to square the numbers. For example, this n is nothing but the number of elements that are passed inside this particular list, that is the square numbers, right? So let's imagine. Okay, I'll explain here. Let's imagine I have n is equal to, let's imagine I have n is equal to maybe 5. Okay, and we also have the numbers, the list, that is the square numbers. Okay, the square numbers is equal to, we have a list that is 1, 2, 3, 4, and 5. Okay, so see here, I have passed the number of elements that are 5, right? And I have passed the elements also, which are 5. 1, 2, 3, 4, 5, right? So now when I pass this particular thing, in return, what I'll be getting is 1 square is nothing but 1, 2 square is nothing but 4, 9, 16, and 25. So I'll definitely get this particular output. Just have a look at. Oh. Okay, so it has successfully run. So now here what I'm trying to say is, maybe here I'm passing some kind of list here, that is 1 comma 2 comma 3 comma 4 comma 5, right? So now I want to apply the function which I have already defined, that is the square function. See here, what I have done is, first of all, I have made a list that is 1 comma 2 comma 3 comma 4 comma 5. So in total, I have passed some 5 number of elements, right? And then I need to square it up. So if I want to square all these elements in the list, what I have to do is I need to define some kind of function, which is nothing but I'm defining here the square function, and here I have passed some kind of argument like n. N is nothing but the number of elements here, and then here I have created some kind of empty list, which is square numbers is equal to empty list, and then I have just run a small for loop using it, which all the elements will get appended to our empty list, that is the square numbers here, right? So here, while appending, I have passed some kind of function. I mean, some kind of operation actually. So that operation is nothing but it will take that particular number and it will also square it up with that particular number, right? So if I pass one, then it will take that particular number as one and it will also square it up with one. One into one will always return one, right? So this is returning the square numbers. So if I run this, see here, what I have done is I have made a list here, list 1 equal to 1 comma 2 comma 3 comma 4 comma 5, and I have used this square function, squares function. Where is this square function coming from? Here, I have already created some kind of function, nothing but squares. So I have used this squares function, and inside this square function, I've passed the variable that is the list one. That is nothing but my list, right? So if I hit shift enter, see here what I have got 1, comma 4, comma 9, comma 6, 16, comma 25. This is the desired output, right? So if you want, you can also try it on some other things. See here, this time I'm only passing some 4 elements, not 5, but only 4 elements. And these are the different numbers when you compare this with the previous list, right? So now, here I'm hitting shift enter. So what you'll be getting is 2 squares, nothing but 4, and 8 squares is nothing but the 64, 6 square 36, 9 square 81, right? So this is the scenario. So what is the purpose of explaining this particular piece of code here? So here, just observe here in the above example, the number of elements is 5 here, right? So it will usually square it up, right? So, but what I'm trying, but the main purpose of writing this particular piece of code here is the space requirement increases with the input size. See, see, what I'm trying to say is the space requirement will usually increase with the number of input size increases. For example, if I say, see here, the elements are 1, 2, 3, 4, 5. So the total input size is 5, right? So let's imagine you will be having the space requirement. So the space requirement for this algorithm would be, what is the space requirement here? That is nothing but order of n. So it is known, it can be pronounced as order of n. Order of n is nothing but this is the space requirement. So this, what is this n here? N is nothing but our input size here, right? So here the ultimate concept involved here is, if this particular n is increasing, then the space requirement for this algorithm will also be increasing, right? So the space complexity will definitely get increased, right? For example, if n is equal to only 2, right? Then what happens? The space requirement for this algorithm will be, that is, the input size has decreased, right? So the space requirement will also be decreasing, right? And if n is equal to 900, let's imagine this, I'm passing 900 elements into this function, right? So then what happens? My space requirement will always be increasing, because if I pass 900 elements, I need to arrange the storage space in which I can store 900 elements. So what would be the easiest one? Storing only simple 5 elements or storing 900 elements? Which one is the easiest? So obviously, storing 5 elements in our memory space would be the easiest one, right? So the ultimate, uh, the ultimate thing here involved is, when the input size increases, the space requirement will also be increasing, and when the input size decreases, the space requirement for this algorithm to run will always be decreasing, right? So so now I'm just clearing all the things here. Okay, let's move here. Okay, so here let's imagine I have some kind of problem, right? I have a problem, and this problem can be solved using many ways. Okay, let's imagine, for the simplicity, let's imagine this problem can be solved using only 2 ways. Okay, So this is the one way, and this is the second way. Okay. So I have solved this particular problem using two ways. This is the one way, this is the second way. So for in one way, I have used one kind of algorithm. Okay, this is the first algorithm. Let's imagine. And in the second way, I have already used the second algorithm. This is the second algorithm. Okay. So when I run this first algorithm, I have got the space requirement as order of n. So this would be my space requirement. Let's imagine this would be my space requirement. And when I run this second algorithm, there I have got the order of n log n. So just imagine this would be the space requirement for this particular second way, right? So what do you think? Which one would be the efficient way of solving a problem? What do you think? So always you need to remember the first algorithm. This algorithm would be greater than the second algorithm in terms of the space requirement. Why? Because see here, just imagine here, this is the order of n. This is the order of n. But when you look at here, this is not the order of n, but this is the order of n into log n, right? So here the space requirement is actually increasing, right? So here the space requirement is actually increasing. So you can say that the first algorithm is greater than the second algorithm in terms of space requirement, right? So here the ultimate thing is when input size increases, then the order of the growth will always be important. For example, here I have said order of n, and here I have said the uh, what do you call order of n log n, right? So for example, if n is equal to maybe 900, then what happens? You need to compute the order of n for this particular input data, that is n, right? So here in this particular in this way, I have used n is equal to 900, and in this way I have used n is equal to maybe 2. So, but you need to understand one thing: wherever the input size becomes the larger, there we need this particular order here, order of growth. You can call it as in general order of growth. So the ultimate thing here involved is when input size data is greater, I mean is larger, then what happens is order of growth will be important. Order of growth will be important, right? Yeah, so that's all for this video, and in the next video I'll be explaining about the asymptotic notation involved in the space complexity, right? So I hope you have got the better understanding about this space complexity. So yes, if you like the video, just uh, subscribe and share it with your friends. I'll see you in the next video. Jai Hind.